If A, B, C, and D are positive integers that satisfy the equations AC plus BD is equal to 34 and AD plus BC is equal to 43, then what is the value of A plus B plus C plus D? Now it is given that AC plus BD is equal to 34 and AD plus BC is equal to 43. If we add both equations, we get AC plus AD plus BC plus BD is equal to 34 plus 43. Now from the first two terms, if you take A common, then you get A multiplied by C plus D. And from the second two terms, if you take B common, we get B multiplied by C plus D. And on the right hand side, we get 34 plus 43 is equal to 77. Or we can write C plus D multiplied by A plus B is equal to 77. Let us call it equation 1. The left hand side of the equation 1 is A plus B multiplied by C plus D. Since A, B, C and D are positive integers, A plus B and C plus D are also both positive integers. The right hand side of equation 1 is 77, which can be written as the product of two positive integers as 1 multiplied by 77 or 7 multiplied by 11 only. Therefore, A plus B multiplied by C plus D can be 1 multiplied by 77, let us call it equation 2, or A plus B multiplied by C plus D can be written as 7 multiplied by 11, let us call it equation 3. Therefore, A plus B is equal to 1 and simultaneously C plus D is equal to 7 is equal to 77 from equation 2, or A plus B is equal to 7 and simultaneously C plus D is equal to 11 from equation 3. But since A and B both are positive integers, their sum can be minimum 2. Therefore, A plus B cannot be 1. Hence, equation 3 is absurd. Before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Hence, the only possible values are those given in the equation 3. That is, A plus B is equal to 7 and C plus D is equal to 11. Therefore, A plus B plus C plus D is equal to 18. Again, equation 3 is A plus B multiplied by C plus D is equal to 7 multiplied by 11. From this equation, we could also have written that A plus B is equal to 11 and C plus D is equal to 7, and this would have made no difference to their sum, which still remains at 18. Therefore, 18 is the only possible answer. However, if you are asked to find the individual values of A, B, C and D, then you can proceed as I am going to describe in the next few minutes. Now, if you are required to find out the individual values of A, B, C and D, please appreciate the fact that if a particular set of A, B, C and D is one solution, it makes no difference if the values of A and B are interchanged and simultaneously the values of C and D are also interchanged. This gives another solution. Similarly, if A, B, C, D is a particular solution, then the pair AB can be interchanged with the pair CD to give another solution. Thus, if we get one solution, we can get three other solutions by swapping the numbers around. Going this way, I have found the following 8 solutions. Try and see if you can find out any other solution or if you can get a general method to get all the possible solutions. Now the solutions that I have found out are in the order of A, B, C, D. It is 1, 10, 4, 3, 10, 1, 3, 4, 3, 4, 10, 1 and 4, 3, 1, 10. As we have discussed, once one solution 8, 10, 4, 3 is found, we can get three other solutions by interchanging the digits or pairs of digits. Here, 1 and 10 are interchanged and 4 and 3 are interchanged to get the second solution. Similarly, 4 and 3 are brought here and simultaneously 1 and 10 are interchanged and brought here. That gives one solution. 4 and 3 are brought here. 1 and 10 are brought here. That becomes another solution. So we get 4 solutions. Another 4 solution would be 2, 5, 7, 4, 5, 2, 4, 7, 4, 7, 5, 2 and 7, 4, 2, 5. So these are the 4 solutions that I have found. Please see if you can find any other solutions. Thank you.